welcome to your next challenge from the medium category. This one's called Factorial Number, and I believe we've done this in one of the previous series. Maybe it was the easy series, but that's no problem. We're all about repetition here, making sure we understand concepts, and so that's not a problem at all. You find that a lot of new programmers, they get overconfidence when they solve a problem once, and then when you ask them to solve it again later, it's not as clear when they go to do it as it was in their head, and they had a false sense of confidence. You may ask someone who came out of school to implement a doubly linked list or something, and they certainly would have done that in college, and I'm sure they had a very good grasp of it at the time. And then when you actually sit down to go do it, you run into walls and you get kind of stuck. So no problem at all. Let's just pound through it again. And then also we could have people coming here that didn't go through the other playlists. Maybe they have some experience, so no problem. Let's just do it again anyway. It's a good exercise regardless. So on to it. Create a fact method that receives a non-negative integer and returns the factorial of that number. So if you're not familiar with the factorial function, it's going to basically multiply out all of the integers from the parameter down to 1. So let's say this first example isn't so good. It's already at 1, so we simply return 1. That's all that's there. But consider an input of 3. It would be 3 times 2 times 1, and you can see that's equal to 3 times 2 is 6. Good. So factorial 6 would be 6 times 5 times 4 times 3 times 2 times 1. And if you multiply that out, you'll get 720. They offer a couple notes. Consider that factorial 0 is equal to 1, and you should return a long data type number. Okay. I think we're good there. We will head over to the code. Again, this is your chance to implement this. Please do that first, and then we'll continue on with the solution. And so this solution, as we mentioned before, factorial is a classic problem for showing what recursion is. And recursion happens when you have a function that calls itself. And so you can imagine that if you're not careful with this thing can just keep looping. It calls itself, and then it gets into the body, it calls itself again, it starts at the top, calls itself again, and you just kind of get in this loop. So one of the very important concepts of recursion is that you define a base case that allows the recursion to stop, that allows you to terminate it and sort of integrate the results. And the other idea is that of progression, that you're constantly progressing toward that base case so you can get out. It's one thing to have a base case, but you have to make sure you get there as well. So let's consider this. We said factorial was an example of 6 times 5 times 4 times 3, so that would come in as fact 6. So you may be inclined to say, return n, which let's say is 6, times fact n minus 1. And that would go to fact 5, right? And then that would produce, 4, 3, or as you think. And again, we run into that problem where there's no base case here, right? This will just keep subtracting. It will go to negative numbers, and your program will just hang and be in an infinite loop. So that's bad. So let's make sure we define that base case. In the case of factorial, we saw that fact 1 was equal to 1, and also that factorial of 0 was equal to 1. So we're going to start by doing a check to see if the input is at that point already. And I'll say if it's less than or equal to 1, this would cover 1 and 0. We'll simply say return 1 at that point. That's what they contribute. Yes, that would cover us in the case we get input 0. So just simply return 1. Otherwise, if we're walking down and we get to 1, this will finally produce a 1 in there, and we'll sort of unwind the stack and multiply all these values out. So yeah, let's kind of walk through how this might execute. Like you said, we had 6 here times fact of n minus 1, which is 5. So you get 6 times fact of 5, which turns into 5 times fact of 4, which turns into 4 times fact of 3, which turns into 3 times fact of 2, which turns into 2 times fact of 1, and we know that fact of 1 is 1. So that 1 comes in, and you basically had this statement that was like 6 times 4 times 5 times 4 times 3 times 2 times, and then finally there's no recursive call, right? We just simply get return 1. There was no return something with another call. It was, no, this is just the value 1 now. So that sort of ends it, and then the computer can perform this multiplication here, and you get your answer of 720. So that's how it works. I have to imagine there are a lot of resources online where you could see an animated version of this process that would make it even more clear if you didn't follow along with what I was saying. I'd be happy to explain it for you more too if you still found that confusing, but I think that's pretty clear. I'm sure I could come up with a resource for you too if you'd like. So we should run it as usual to make sure it works. Now let's check it out. Cool, we passed all of the test cases. If you want to look at them, you may. They did, sure enough, try and get us with that 0 input. And you can see the numbers get quite large here. Factorial blows up very quickly. So, yeah, that was the key thing. Recursion is a very powerful tool. It's definitely something you want to keep in your tool bag. So we had here, we determined this is recursive because it's referring to itself, it's invoking itself, and we talked about having a base case to terminate so we don't just loop forever. We talked about progressing toward that base case, right? We were subtracting. We, for the most part, were receiving values well above 1, and we were always decrementing down toward our base case. We were moving towards it. So remember to do that to avoid trouble with recursion. Other than that, yeah, I think we're good. Hopefully you found that useful, and I'll see you in the next challenge. Thanks.